why database are vulnerable actually on the cloud? This was the question at the beginning of the class actually. Usually everything exposed in a public platform is vulnerable since it is exposed because the least
أستاذ،
vulnerability or issue is the privacy. Yes, tell.
في بنات يريدوا يدخلوا قبل شوي مخلصين
Ryan,
من
I said,
اختبار.
Ryan, I said, I have no notes here. There is no notes here actually. I'm not receiving any message. Usually, actually, I'd have to receive a request, but it's not visible. Ask them to reopen or close and reopen again the link again to access because it's not showing me. ما يظهر لي. Ask them to access reopen. So I was saying that the issue here was um, due to the public actually exposure. Everything in a public framework is exposed and the privacy is broken, and this is the least vulnerability we can discuss. Yet, the question said on the cloud specifically. The clouds, there are types, and mainly we talk about three models or three types of the clouds: the public, private, and the hybrid. If it is a public, so the same context is exposed, but the most secure one is the private one. And still, since we are talking about a network, we have issues. As per an example, I can discuss the issues coming from the insiders, script kiddies. Those are types that we can face on a private cloud because not all the users of the cloud, they are experts in security. They are dedicated to different tasks to do, so they might play the role of insiders or the script kiddies or something like that unintentionally. Thus, it is usually vulnerable since it is on, let's say, www environment or even the cloud with its three types. Continue from where we stopped. Actually, this chapter actually we are about to finish. Uh, let's just go on. We were here. I remember actually the last thing we discussed. It was the injections, the context of the injections. Usually, whatever the diagram you are seeing in front of us here, it describes a path via which a user can reach a data store, which is a database, and the path it is through different nodes. This is the client here, and this is the resource he's asking to access. The green line is the path he's following to reach from his place, his computer, until the let's say database, which is the database through the data source. Yeah, this path might be actually short or long. It might be through a public or private network, let's say, but here clearly it is said that it is through the internet. So 100% it is a public one. Uh, Here the security concern gets imposed, and from the concerns is the injections. Usually the first threat I said, against the database is the SQL injection, the injection and specifically the SQL injection. There are models of injections that we may discuss or may find. It's not one type. We say SQL injection or SQL injection. Okay, which one? Because there are models, there are types. I come and discuss this example again, but there are types of SQL injections, tautology and of line commands of PG queries. Queries actually, uh, those are scenarios via which how we submit or let's say inject the SQL queries into the input points to interrogate the database or the database in question uh, in a non-legitimate way to say that this is an injection. It's not an interrogation of the database. It's an injection since it is non-legitimate. Okay, look, I come back to very briefly to the first example here discussing the SQL injection. We have an input point. We have an input point, and through this input point, we required to let's say input the data, whether it is username or something like that, whatever. So something like this. So something like this interface here, we are required to input the data, which is username and password. Yet instead of typing what we are required to type, we type something similar to this. What I'm highlighting right now, fully. What I'm highlighting fully. So username, single quotation, semicolon, query, new query, termination of the query, semicolon, and start of a command. Fully, we type this one. So instead of typing here, as per an example, I'm taking an example of this actually public framework. Instead of typing username here, which is an email is required, and the password here is in the email itself. In the email itself, we type the given. Let's say, okay. Actually, I'm not going to explore that, but that's here to say that this is where we start by the SQL injection. So what is the problem, and what would happen actually if we do so? What we are going to do is we are passing this value. Somebody is coming in, and Hanuf. Okay, there is a value to be submitted to the compiler, to the interpreter. Then we terminate this value to be read uniquely. Then after we send another query. This is the one we terminate it, and then after all what it comes in the program later on is going to be considered as a command because we passed this command indicator, the single line command actually in SQL Server environment. What does it mean? It means the program in question, the one we were seeing as per an example, will use this value here as a value to match his request here. So select first name, something. He will read Mrad here, exactly. And the single quotation would come here, single quotation. Then the semicolon to terminate. Done. Then what? This full query would come, then the termination, then the indication of the command. Here, it would come here. So here we are terminating the query. Great. And also we are passing another query. And also, if there is anything later on to cause a trouble as an error, we are setting it as command. So there will be no errors. The program will not launch any error. It will pass if it is not validated. So it will pass. Actually, the computer will execute this thing. He may find 0 results, but he will execute the second query. And if there is a table named cause, this cause table will be dropped. And this is a danger. And if there is any error later on to be launched, no, it will be actually handled using this command indicator. Great. So this is a sort of, this is how the SQL injection happens. This is the story. How the SQL injection is happening, how it is running, how the system is receiving injections. Okay, great. Another example actually, which is very famous. It is much more actually easier than this context here to understand, easier in context of understanding for a first view. Why? Because see, we compare this statement here, value terminate, query terminate, hyphen, or let's say command indicator, and that's it. How many statements to be handled here? Let's say 1, 2, and if you consider the comment as another statement, so 3. Here we have only 1 because we are going to pass a portion of a query. See what I'm highlighting right now. Single quotation, space, or space 1 equal to 1, space hyphen hyphen, comment indicator. So here, if we take this value here, we're going to type it in the, let's say, any here actually taking this example here, but it's not the case. If we succeed in, if this system here is not doing the input validation, this query will return true because 1 is equal to 1 usually. Thus the system will let us pass. When we compare it to what we had to give in the query, so here instead of the username, we are going to give what is written there. So single quotation to terminate the query. Oh, this is SQL, let's say, comparison operator. 1 equal to 1, usually true. So either this or this, any of them, if it is true, so this one will be executed. So thus, this one is usually true. Thus, the system will execute. It will retrieve the first name of all. And if there is any error to be launched later on, no, it will be handled using this comment indicator, those 2 hyphens. Another actually this attack is said to be nominated the 1 equal to 1 attack, or the tautology. The tautology is the 1 equal to 1 attack. Why? Because we use a value. We can say here a equal to a as a character. Not only to be 1 equal to 1, but it has to be actually a matching value. We may say 2 equals to 2. So it is something to be validated, no more, no less. It has to return true usually. So the tautology is to use something like the 1 equal to 1 as a value comparison to return a true in all cases. So usually it has to return a true. Second, let's say, type of SQL injection is the end of line command. The end of line command. It is very similar to the 2 examples we saw, and it is very similar to the tautology as per this example here, as per this explanation here. Why? Because at the end we are passing a command. At the end we are passing a command. Because what would come later we don't know. As per the example we were seeing, we need a username and a password. So to avoid the password checkup, only we need the username, for example. So we put comment here. So the query will be terminated, this one, at the level of the command. All what comes after will be neglected. Here we are saying end of line command. So instead of, for example, comparing or checking the username is valid or not and the password is valid or not, so the system will check only the username, because the rest is a command. It's commanded, change it to a command. It will not be actually checked by the system. Third type, let's say, SQL injection type, actually, other attack, also we can refer to that, the piggybacked queries. This is another view of the same description we were discussing. Why? Because when we look to this example, how many queries? I was talking here and I said we may consider that here we are generating because of this input. Here, if I just copy this one and I put it here, the user, if he types this value in the input field, how many queries we will be having? We will be having query number 1, query number 2. Then after, if we consider the command as a query, so it would be the third, number 3. So 3 queries. What does it mean? Means it is backed of queries. there are so many queries in the same field. So here, let me give it to you here. So here, instead of typing the username, email or something, I'm gonna type this reply, username that I suggest, single quotation, semicolon to terminate, then the second query, then the command. So we have more than 2 queries to pass, and that's what we're talking about a piggybacked queries to be submitted in the input. Here, actually, backed or baked, the pronunciation, to be input in the input field. Actually, this process is not it's not legal, it's not legitimate. Username and password fields, they are not to be passing list of queries in one field. No, they are to be utilized for passing usernames and passwords only. And this is non-ethical, non-legitimate, and this is a crime, digital crime. So this is a threat in the cyber environment. This is a threat. Piggybacked or piggybacked queries. Do you have any questions in this regard, the context of the injection, the SQL injection in general? Do you have any concern?
No, doctor.
Okay, great. We continue. A database is controlled actually by a DBMS engine, which is a system that hosts, or let's say hold, the database in question. And thus the access control to the database as a source might have more than one layer, and we can see the DBMS in question controlling the access to the resource in question, so the database. What does it mean? If we take the SQL Server as a database management system, the SQL Server will control the users from accessing the databases. Sorry, the request, they are saying that they were in an exam actually, but I'm not receiving any request of access, so I'm not seeing any request. What I was saying, yes, here is Maria. Okay, so the last layer access control to this as an access control to the resource or the source of data. Let's say the requirement is the DBMS itself, the engine where the database is resided. So we were discussing the access control as a full chapter, the chapter before, and we said that those are filters to set on top of all the requests, all the authenticated requests to access resources. Okay, the last resource here we have a database. Here we are going to retrieve the usernames from a table. Okay, the last control to set on validating this request is to be done by the DBMS in question, database management system. Taking the example of the SQL Server. SQL Server is a Microsoft database which would have the capability to host many databases. Students, let's say, can access the database for different reasons. Faculty or instructors may access the database for different reasons. Technical people may access the database for different reasons, and so on. So all the requests, they would be passing through the DBMS. So the DBMS is the last layer to do an access control. Access to what? To the database in question. Database number one, database number two, and whatever. We may set the access control from whether the database hosting the databases, database management system hosting the databases. And usually, remember that the access control is to be applied or is applicable to the authenticated subjects. Subject that they have been actually authenticated, so they might pass through the access control filter. Otherwise, no. All the capabilities actually to be done here on top of the device to give the access, the functionalities to award the authenticated subjects are what? Are context of DML and DDL. Because we are going to interrogate the database. What to do? We are going to use only the SQL or the interrogations or the communications to be with the database. All are only SQL queries. And since they are SQL queries, they are either DDL, data definition language, or DML, data manipulation language. DDL means sort of create, alter, truncate, not truncate, alter, drop, yes, data definition language, or data manipulation language, sort of insert, update, select, manipulation language. All of them, they are, in our case, they are SQL queries. The user, for example, user number one, is allowed to only select. Read means he cannot insert new values. He cannot create new entities, new tables. He cannot. So this is sort of a right given to a specific user. Okay. Another user, he is given the right to write means to insert DML. Okay, he can insert and he can only see the values he made, because if he does the insert, it is trivial to see what he did. So to read also. He cannot create entities, he cannot delete what he inserted, even he cannot update. So those are restrictions to be set on a specific subject, authenticated user. Not only those rights actually to be set, means not only those capabilities to be set by the DBMS. What does it mean? Means the DBMS, it does not have only to allow subjects, authenticated users, to either create, insert, update, and things like that. Not only this. What does it mean? And what are the other things? The other things is that the architecture of the database to be utilized specifies the rights that the DBMS would give the access control. When we talk about a decentralized database or decentralized system on top of, let's say, use a project on top of the use of a decentralized database. So we have more than one location where the database is available. Users will be authenticated and then after will be given access to different locations. Thus, there will be politics controlling those sorts of, let's say, architectures. Those are examples only. But the rule is the DBMS should accept politics to run and to award access to the resources. Those are trivial because those are from the nature. When you say that the DBMS will allow the insert, the update, the select, or whatever. Yes, this is the nature, the SQL. Okay. But what it is not from the nature, from the original architecture, how the DBMS has to run, is the policies to admit to help in running those, let's say, features or sort of architectures, how to run the system, the project. Politics, remember, politics are policies. They are also supported by the DBMSs to manage the access control. It is not only actually as an attack when we discuss the SQL injection. It is not only related to SQL injection attacks that might influence the work and the flow within the databases or within the projects that they use databases. Infrastructure attacks is another kind of threat that influences the good work or the good willing of the projects run in databases. At the beginning, I told you that I gave you the question and I answered saying that the publicly set or given displayed databases, they are vulnerable from the day zero. Why? Because the least vulnerability, the least issue to think of is the privacy. What does mean? Means if you talk about gathering data related to different parties, different objects, different subjects, and so on, this data gathering, we saw that actually in the lab at the beginning, the enumeration and the reconnaissance, is a sort of actually a cyber attack to do. The probing is a cyber attack. So it's in the same category here. It's in the same group. Recognize how a system is running, the framework, the operating system used to run the project, database management system, model, type, or name, yes, provider, and so on. So this is a sort of a data gathering, and it would happen by just doing an inferential attack here, and this inferential attack is by just interfering queries, interfering requests and responses, and analyzing the content without any alteration. Static attack. It's a sort of a static attack. This is a legal process. At the end of the day, this is a very clear illegal process. And this illegal process, it is not only to be done by the attacker. What does it mean? If there is no input validation in the input fields where the databases receive the requests, attacks they might intentionally do input falsified queries, means illegal queries. And those illegal queries, they would help the attacks achieve their goals. What is the goal? Is to make the system, the DBMS in question, display falsified, or let's say error messages, notifications, warnings, and all of those notifications and warnings and messages to be displayed, that would help the attacker recognize the project environment or the system environment or the database environment much more clearly. And this would help them later on to go deep and attack further, because I reached to gather the needed information here by just setting and passing illegal queries. And this would happen due to the non-set security, which is the input validation mainly. So to pass an incorrect query to the system and to let the system send an output actually, which is an error message or a warning or whatever, just it is a technical display. is not handled. This would for sure help the attackers to gather the needed information for the needed for whom? For them only, to use them for further interrogations in future. Yes, because if I know who you are, I will know how to attack you later on. So the information attack, it's the context of knowing the system environment, to know what the system environment is for a further attack, because this is a very static attack. What does mean static? It is only to see, it's only to know. That's it. They will know. To know information. It's informative attack, sort of informative attack. It would not have as much as it would actually only expose the content. After exposing the content, later on, other attacks or other actually activities on top of the database would happen. Any questions at this level, please? There's no questions. Okay, it's great since you do not have actually any questions. Yes. You understand them. And Hanuf, any questions, please, before I pass? Hanuf? Hanuf, are you here?
No question.
Okay, Ryan, thank you. Hanuf, are you here? Hanuf? Okay. Another sort of attack to be happening on the database, actually, another kind of another category, an attack to happen on a database, which is the outband attack. And this outband attack is to explore the limits of, let's say, the use of the database within a project.
Yes,
What
Mr.
are what are the allowed usages, and what are the limited
Mr.
usages? Okay, Hanu, okay, no worries. And it is said why outbound, because the database, even after the limitations, it is to be utilized and to serve requests, but in a lax way, in a very lazy way, let's say. So queries to pass to explore the limits, the limitations of the database, and based on that, there will be other requests to explore the capability and to explore the content, actually, which is intended to be limited at the beginning, out of the band. It is at the beginning intended to be limited, but in a way that the server, actually, the database server, we talk about, as per example, the SQL server, the DBMS, will serve still, but in a lax way. We continue next class, inshallah. If you hear your name, just say yes.